these are striking in. And again, you know, if I just turn on shaded here, you can see they're only sticking in that much. There we go. And you know, if we change this to 2000, then as you can see, our arrows actually stick much further into the surface. If I change it to 1000, they'll just go in too far, really. There's, you know, they've embedded themselves all the way. Obviously, the further they embed themselves, the more ridiculous the sort of wobble looks, because you can see it shouldn't really wobble if it's embedded himself that far. But again, you know, in a more complex version, you could modify that to actually take that into account, and have it so that really deeply embedded arrows just don't wobble. Only the slightly embedded ones do. So that's quite an interesting control there. So I'll just put it back up to, say, 2500. There we go. So our arrows now striking the surface and stick in a reasonable amount. That's it for the arrows that strike the hard surface. Let's have a look at what happens to the arrows that strike the harder surfaces, the ground and so forth. You know, this is obviously just a soft surface wood. The arrows that strike the hard surfaces, they get split. You can see 50% of the arrows are sent off to be subdivided even further. So you can see we send off 50% here, and we then send off another 30% here. In the first option, we actually have the spin. You can see the spin rate here is set up. That's actually to give a sort of cartwheeling motion. When it strikes the hard surface, it does a sort of strong spin, as if it's, you know, struck a rock and it spins off wildly. We've got gravity to obviously pull the arrow back down to the ground as it goes off spinning. We've got the collision detector again, because this arrow obviously isn't going to stop dead. It's going to carry on moving, and therefore it needs to deflect off the ground and whatever. It also deflects off the teapot if that's the case. We've got shape instance, and we're using wobbling arrows again. And again, as I said, that's just using the wobbling arrow model. As it goes cartwheeling off, it wobbles as it flies through the air. The other 50% come in here, of which, as you can see, 30% are sent onwards. So the ones that actually remain in here, they spawn. As you can see here, spawns 2 parts. The speed is set to speed space. The spin, I should say, is set to speed space, and again that gives us this sort of crazy spinning off motion as the particles go careening off. We've got gravity. We've got collision detection with the ground and the teapot again, and in this case we've got shape instance, and we're using 2 parts, and that means that our arrow, when it strikes the surface, breaks into 2 pieces, and we randomly assign, you know, one of the 2 parts of the model to the 2 particles, and that should give us the arrow and the rest of the shaft, and then it should cycle through those 2 different values. The remainder of the arrows, they get passed on to here, where they get broken into 3 parts, which as we showed you earlier, we've got this 3-part model. You can see it spawns 3 particles, which is the 3 parts of our arrow. We spin the particles again. We use gravity to pull it down to the ground. We deflect it with the ground and the teapot and so forth. And then we use shape instance to use broken 3 parts, and that gives us the 3 parts of the arrows. So that's basically it. That's our little arrow effect. As I said, you could make a more complex version of this, where you use a lot of scripting and a lot more different events to give you much more control over exactly what the arrows do when they strike different surfaces. As I said, we could use a sort of scripted system to have the arrows being fired only when the archer releases the string on his bow. We can have lots of different effects. There's no wind effect in this. If you had a much longer fire on the arrows, then maybe you could have some sort of wind effect coming in to give us some turbulence on the arrows. You wouldn't want too much, obviously, because arrows really generally fly pretty fast, but you probably not that much turbulence, but maybe a little bit of wind to make them drift as they fly through the air, which is, you know, quite realistic. In a wind, you would have to adjust your aim to compensate for the wind. So there we go, a very interesting effect, something that you can develop, and you can also do different versions based on other weapons. You know, you could do ones based on javelins, spears and so forth. It's something that you may come across and may need to do probably in a film more than anything, rather than, Maybe for a TV series as well. Also, you know, that kind of thing would turn up in a lot in a TV series. Maybe not that useful for advertising, but as I said, it's an interesting effect, and it'll certainly give you some more ideas for other effects. So let's move on from here and have a look at our next effect, which is a laser etching effect, where we use a laser to cut text into the surface of a sort of metal block. Okay, let's do that now.